I do work at BYU-Idaho. I love my job there. I get to interact with amazing young people. It is such a great blessing to be around them, not just for their energy and that sort of a thing, but what they can do. It's really amazing. Really just astonishes me every day. Some background. Before I started working at the university, I was in industry. My first job in industry was working at a company where we did planning and scheduling software for semiconductor factories, both the fabs and the assembly test sites. And that was a fun problem to work on. So, you know, we worked in coordination with other parts of our company that were doing factory automation software and lots of really, really interesting things. I did many roles there. You know, it was my first job, so I started off as junior programmer, and then over time, you know, things happened. I was eventually senior software engineer. They made me quality assurance manager for a product for a while. I was a development manager, you know, et cetera, et cetera, et cetera. And by the way, my opinion is every engineer should be in quality assurance at some point in their career. So I had some very interesting interactions with people that had not been in quality assurance. So if those of you who are running companies, give your engineers that opportunity. I think you'll find that the flow of information between your engineering team and your quality assurance team dramatically increases. So after that company and I decided to part ways, I started my own company. And what we were doing then was mobile software for home health care nurses. Now I know what popped into your head. Was it Android or iOS? And it was neither. It was before either of those systems either existed or was useful. And so I was actually writing mobile code on a Palm Pilot. And those of us of a certain age will all recognize how much we're glad we don't use those anymore. The back end of that was enterprise Java. It was what was scalable and available at the time. And again, that was another fun and interesting thing to work on, to help home health care nurses to not violate the US federal government's laws about security of data, because they did all the time. So after that, I came to BYU-Idaho. And when I saw the opportunity to teach, I jumped at it because I just love teaching. I just always have. Prior to going into the industry, I actually taught junior high, and I did that for 7 years and loved every minute of it. And so that's how crazy and nuts I am. I love teaching junior high. So that's a little bit about me. I am presenting something here. I don't have the clicker thing. We need to move to the next slide. Is this it here? Oh, is this it? There it is. There we go. Thank you. All right, so BYU-Idaho is one of a group of 5 sister universities, all sponsored by the Church of Jesus Christ of Latter-day Saints. The one you're probably familiar with is BYU. That's the one that has the football team and the basketball team. And it's a research university, very kind of standard in its structure. They offer graduate degrees, masters, PhDs. They're a regular research university. Each of these universities and colleges has its own special purpose for existence. And so as I'm presenting a case study to you, I need to tell you what the situation is so that you can understand the case and the data from it. And so I'm going to talk about how these things are related to each other and how they're distinct. BYU Hawaii, the one almost on the bottom there, is a university that is dedicated to helping people in the Pacific Islands and on the Pacific Rim So the students there are going to often be from those areas. Every once in a while, there'll be a student from some other area there. But the idea is help people to get education so that they can go back to their communities if they desire and lift everyone there. Ensign College, sorry, I gotta say it right, it's Ensign, by the way. Ensign College is more along the lines of a community college. So they're focusing on certificates and associate's degrees, and they do offer a couple of bachelor's degrees, bachelor's of applied science kinds of things. BYU Pathway Worldwide is the newest of these universities. Its focus, again, is very different. There are many, many people out there in the world who want to go to college or want to have increased educational ability, so that they can improve their family and their community's lives. And yet they don't have such an opportunity. Maybe they've never even been to a secondary school, and yet they want to improve their lives and those around them. And so BYU Pathway Worldwide is the university in this suite of universities that is tasked specifically with that. They have a program called Pathway, which takes someone who is not ready to go to college and prepares them to go to college. Students that register for that are often non-traditional students. I mean, that's the focus of this area, is non-traditional students. And so, I just lost my train of thought. Oh, well. Anyway, so they're helping the non-traditional students, and the cost of that is different depending on where you live. So in sub-Saharan Africa, in Brazil, and in other places where there's large populations of people, the tuition is heavily subsidized. And in fact, I looked it up just before I came, and it's $4 a credit hour in sub-Saharan Africa and in Brazil. And someone who starts in BYU Pathway Worldwide can choose to go to BYU-Idaho if they want, and matriculate over to our university and come to Rexburg if they want. They can go to any other university that will accept them as well, and they are well prepared by then, and they generally get in. When they come to join us, or they go into the online courses for Pathway Worldwide, their tuition amount remains the same. But all of the tuition is heavily subsidized by the church for all of the students at all of these universities. So that's kind of where we reside. Oh, I haven't talked about us. Let's talk about us, about BYU-Idaho. BYU-Idaho, the reason for its existence is to help people be prepared for industry. And if they want the option of going on to graduate school, they can. So we provide bachelor's of science degrees across all kinds of curricula. All of the STEM stuff, dance, music, business, communications, all of those things that you would think of at any other university. But again, it's heavily subsidized, and we don't do bachelor or graduate degrees. And so our focus is very much on the student and helping them be ready for you to hire them. So if you want to hire somebody, I'm happy to talk to you. So where are we? We are in Rexburg, Idaho. It is a very small town. The university is the largest employer in the county. We are at the eastern end of a very large valley that spans all of southern Idaho. If you drive from one side, from my house to the capital of Idaho, which is on the other side of the state, it takes 5 hours, and you never leave the valley. So it's a very large valley, and that's why you can see some amazing sunsets. And it's a beautiful place to live. If you want to come and visit, I would suggest July or August, because it does get a little cold. It does get a little cold. So I've got some honesty photos up here with snow. Okay, so I don't want to mislead anybody into think it's like, you know, nirvana 24 hours a day, all day, every day. But the building that you're seeing here is the building that I work in. Amazing place to teach. One of the things you'll find in this building and in the other buildings on campus is places where the students can group together. One of the important things about, we believe in BYU-Idaho is in gathering. And being together helps everyone. And so we give students opportunities within the buildings to gather together just as friends, to work on their projects, whatever it may be. And you can't see it because it's too far away, but there's all kinds of chairs and couches and things at the end of this part of the building. And right over in here, there's a series of small 5 to 6 person rooms that students can actually schedule and meet with their friends and teams. All right, so now let's get into some data. What I've done here is at BYU-Idaho, we have a non-traditional calendar. A traditional calendar would be 2 semesters and then a summer where you kind of cram everything together for a few students that want an extra educational experience. We have 3 full semesters a year, and because of that, we graduate students 3 times a year. Okay? Students can be in one of 3 tracks, is what we call it. They could be in a fall-winter track, a fall-spring track, or a winter-spring track. And what I've done is taken each of those semesters and just plopped the data for how many students there are. Now let me warn you, it is very difficult to count students. How do you count part-time students? How do you count students that are online students sometimes and on campus other times? So all student count numbers university-wide are going to be very loose numbers. But you could take these numbers that you see up here and drop them by around 30%, and that would tell you how many students approximately we served during the year. So while Rexburg is a very small place, we're serving a lot of students every year. And we do that in the computer science program as well. This is university-wide. So we had a problem. We had a fairly traditional computer science curriculum, and we were losing almost all of our students. We had a very low retention rate, very low retention rate. There were many reasons for it. The biggest reasons happened to be the first programming classes they took. The retention rate for those classes was 50% for each class. So you'd lose 50%, then you'd lose another 50%, and then 50% of the remaining. Well, I mean, yeah, we had really high employment rates, but we were not able to help students who would really be excellent workers and employees in computing because they were bailing on us. Some of them would go over to another department, the IT department, which is fine. You know, IT's great. I love them. Right? They're the ones that keep me up and going and available, and so I can do things. But we wanted to retain those students if they were truly interested in computing, as they had expressed that interest at the beginning. And so we decided that we were the problem, and we needed to make a change. So the first thing we did is, how are we going to make this change? What are we going to do? What goals do we have? And so we listed out some of the goals. Obviously, we wanted to increase our retention. That was a no-brainer. It would be sad to lose all of those wonderful students. We wanted to make sure that our employment rate stayed high or increased. And then these last two, those are a little trickier. So we decided that we would go out and we would do some research. Strange, huh? A university doing research. So we went to a series of employers that hire our students, and we went to a series of regional universities around us that offer graduate degrees that our students tend to go to. And we asked them what their ideal employee would look like. Could you give us an example of someone that you hired that was just stellar, or a student that was just stellar? And we would gather up this data. And we followed a process called rapid qualitative inquiry. That sounds all, educational and ivory tower-ish and all that kind of thing. But really what it is a structured process that is very similar to what businesses do when they go out and talk to their customers to find out what they want and what they need. And so we were very comfortable with this, even though we're all quant people, right? And it has that word up there, that evil word, qualitative, because, we don't care about quality, right? We just care about numbers. So we did this, and what we found was very interesting. There was zero difference between what the graduate schools wanted and what employers wanted. Zero difference. And it shocked us how low the bar was. Okay. It really did. It was really shocking to us. We thought, well, it's going to be like this, and it's going to be like this. So we're very glad we went out and did the research. So after we did the research, we sat down, we did all of our coding and figured out, okay, now how can we meet that? What changes do we need to make? And this is what we came up with. So over here on this side, you'll see what we refer to internally as the left-hand side. This is a series of courses that are required regardless of if you're taking computer science or you're working towards a software engineering degree. It includes things, all kinds of fundamental things. The idea is to right lane students, get them into what they're interested in early, help them discover what they're interested in, rather than getting a long way through the degree and going, I really wish I had gone over there and worked on the computer engineering degree. I hate what I'm doing, I'd rather be there. So trying to help them right lane and delay that choice as long as possible. It's also their first internal to us programming experiences. And so we start them off in Python. And there's 2 Python classes there, the programming with functions, and then there's one up there at the top in programming building blocks is what it's called. Those are 2 Python classes. We selected that because it has that low learning ramp, okay? After they've completed those 2 courses, they continue on. Programming with classes and programming with data structures is done in C#. And then they have this applied programming course where they pick a language, not necessarily one they've been taught, and they pick a project, and they go out and they create this thing. And our job is to herd cats in that class, and just to help them achieve what they want to achieve. After they've completed the second Python programming course, they can branch out, and we take them over into Clojure and Erlang. Up at the top is a set of courses that we believed at the time would adequately represent everything and beyond what the graduate schools and the employers were asking of us. But what we felt was kind of the heart of computer science. And so you can see some very traditional sounding classes there, and some that are not. The algorithmic thinking class, that's for freshmen, because there's this word algorithm out there that scares the bejesus out of everybody, and it's magic in movies, and well, they're using an algorithm. Well, I mean, it's just ridiculous. And so we help them realize that their life is, algorithms is what they're using every day. It's how they order their lives. It's how they get things done. You'll see we've got an algorithms and complexity class in there. We feel that's very important. We actually do that functionally rather than in C style. Once they are along this path, they will begin to choose between a functional programming certificate and a machine learning certificate. These were the 2 that we felt we could do right off the bat with the skill sets of the faculty that we had. It was scary. I'm not going to mince words here. This was scary. What would students do? I mean, students vote with their feet, and they sign up for classes, and classes that are under-enrolled get canceled. And so it was pretty scary. Would they understand what we meant by functional programming? Everybody understood the AI machine learning stuff. All the students knew what that was. Okay? But you can see there are some things in here that I think are very fun. The patterns in functional programming class, that covers patterns that hopefully we're all familiar with, right? Functors and monads and monoids, and also all the data structures that you can think of. And so the students write code to create all of those. That one they can choose either Erlang or Clojure. The first time I taught that class, all of the students had experience with Clojure, and by week 3 they were all using Erlang. So they voted with their feet. The parentheses, those got in their way. That's what they told me over and over and over again. The capstone class, I'm teaching that one for the first time right now. My students are working in that right now. And that one requires Erlang, and we teach them OTP, and we might use someone's book as a source. I don't know. But an Erlang OTP class, massive scalability in the cloud, HTTP, receiving that. The final, not the final one, but the first project, so it's broken into 2 halves. First half semester is introducing them to all the OTP constructs and abilities. The second half is projects. They have a required project and then a personal project. The required project that we have them do is to replicate UPS's package tracking system at scale, so that it could actually receive millions of package moves in a second. That's the idea, okay? So we're teaching that one for the first time. My students in that class are very brave and being my guinea pigs. And we already know that we're changing stuff there. But the content won't change, but the order that we're doing things and such will change. Come on. There we go. So there are some things that really have worked out well. And it's wonderful that they did. The clicker isn't clicking. There we go. So here's something. Remember, we were worried about the machine learning thing? What if they all choose machine learning? What are we going to do? Oh, no. They all know what that is. Functional programming, none of them know what those words even mean. And what do you mean? Doesn't all code function? I mean, they just don't know what it means. And yet, this is the reality. Now, these are numbers from 2021, so last year, that we pulled out just for this presentation. This is all preliminary information for our case study. We will have some final stuff later on. So this is covering 170 students. And I don't think we have to worry about them all choosing machine learning. We don't know exactly why this is the division that's happening. I'm sure we'll find out, but we don't have enough valid data to actually say why this choice is being made at this time. We had this concern too, right? We had retention problems in our previous setup. So are we going to be able to retain our freshmen? And lo and behold, we can. So this is the number of our students that stayed in computer science or switched to another degree. It does not include students that left the university. We didn't, as faculty, have access to that information. So that is not included, but BYU-Idaho's reported attrition rate for freshmen is lower than most universities. It's not something we're happy with, and we wanted to get it way, way down, but it is significantly lower than most universities. Here was another thing we were worried about. Oh my goodness. What happens if they get up there to the top end and go, no, I'm done with this? Okay. That was shocking when we looked at that number. That was shocking to us. So that tells us that our right laning situation is working as we hoped it would. Obviously, we're missing out on 8% of these 170 students, but hopefully we'll be able to tweak things so that it will be even better. We have some ongoing concerns. The big one, where are those students leaving? And I think the chart is kind of obvious. This is a trailing indicator. Before we gathered this data, we kind of figured that's where it was, just from students talking to us. And so we were already actively making changes to what we were doing in discrete math. It's not that discrete math is beyond them. It's not. Are we presenting it in a way that they can consume the information? Are we presenting it in a way that it is relevant so that they want to continue on, so they can see how they're using this? And we've been making major strides and changes there, so I anticipate personally that that is going to significantly drop in the near future. We're not dumbing anything down. Don't go there. That's not what we're doing. We're in fact asking more of students as we go through this process. Okay, so not everything is a bed of roses. There's always something, right? We're engineers. There's always something. Well, branding. Branding was a problem, right? I mean, nobody knows what functional programming is, so this certificate, how do we name it? How do we name this course? Is that really what it is? Very hard to name these things. As I'm sure you've experienced, right? Get 10 engineers into a room and ask them what the name of this function should be. It may be a while before you leave, unless it's an obvious name. And so if you would like to help us figure out how to name these things, we would be overjoyed. Because functional programming, that's just what a bunch of engineers could come up with in about 15 minutes. And we don't like it. We prefer our certificates to have the name of a profession associated with them. We can't do software engineering because there's a whole other degree called that. So we can't put software engineering up there. But if you would like to help us. What was that? Scalability and reliability. Yeah. Send me an email. I'm happy to hear. All right. What else? Course materials. You just can't walk out and buy a good book on functional patterns and data structures. Did you know that? Did you know that you just can't walk out and buy one? Who'd have thought, So we've written material for those classes there, okay? In fact, the last 3 on the written list, I had to do it. It wasn't something it's okay. I've written a lot of things before, and I can write some more. It's not a problem. We still find that the materials in these areas are insufficient. Almost all algorithms and complexity textbooks use C-style pseudocode. And you hand C-style pseudocode to someone and ask them to write using functional design and programming instead, that for somebody that's new to this, it's just not good. It takes them way too long to do the conversion in it. And it can be really tricky. It can be really tricky. So I'm actively working on that right now. And in fact, I took all of the C-style pseudocode and converted it over to functional pseudocode in the Leviton book that we're using. All right, the future exists in somebody's head. So these are concerns that we still have. Should we add a more traditional certificate? The employers and graduate schools aren't saying we need to, but there's probably some set of students that really would like a class in state machines, in other things. And so we wouldn't necessarily be meeting their needs right now. So that's one of the things we're considering. We're wondering if the reason that students are taking a functional programming route is because they have already completed calculus in high school. And so there's one less class, and it's the shortest path to graduation. Least path of resistance is a thing. Is the language depth sufficient? And should we give up some of the breadth to get more depth? There's positives to both. Okay. This next to last one has been a concern of the students. How do I find a job in functional programming? Well, they're qualified to get a job in OO if they want to, But if they're preferring functional programming, it can be a little tricky. It can be a little tricky. And then the one I mentioned before, the insufficient branding. So we know we've got these concerns. We've got other concerns as well, but these are the ones that I thought would make the most sense here. So that's what we're doing, and that's the initial data. I hope this has been useful to you. I know it has been for me, and in our department as we have gone ahead and made changes and then gathering the data on it. So please ask me questions.
Does anybody have any questions for Lee? Nope.
So picking the functional track, how much did you influence the students versus letting them choose?
That's a good question. How much of it was my influence as opposed to just standing back? I felt I had a responsibility to the students to tell them what this functional certificate was, what they could accomplish with it. And so I would actively do that. And then our department, the Computer Science and Electrical Engineering department, as well as the Computer Information Technology department, every semester we have a big to-do where we give out pizza and invite all the students in. And we have different people representing each of the different certificates and tracks and things, and we can present to the students so that they can make a better choice. And so probably a good chunk of it was probably me. More questions, please.
So when do you first introduce the students to functional programming? It sounds like you kind of start them off with more traditional stuff, and then like around junior year, you teach them Clojure?
So those first two programming courses, they've usually completed by their end of the first semester of their sophomore year.
How did they respond to the switch?
How did students respond to the switch? Yeah, that's a good question.
Yeah, like I remember, the reason I ask is because like learning Clojure for me was, like I was a hobbyist programmer. I've never taken a class, but that was kind of when I learned like, okay, there's someone smart out there whose brain works the same way that mine does. I could actually do this professionally, which is pretty much backwards for most people. And I don't know how much of that is just my brain is weird versus I would be interested to know, like, are they repulsed by the parentheses? Does immutability scare and confuse them? What's it like?
Yeah, okay. So your first language dramatically impacts everything else you learn. As an example, years ago, I read a blog posting. It was by a computer science teacher in a high school, and he was teaching all of his students Java. And he had one of the mothers of one of his students come in and say, would you teach me programming? And he said, he decided he wanted to do an experiment. And so he said, well, would you mind if I taught you Erlang first? What does she know? She doesn't, she's never written code in her life. So she says, yeah, sure, whatever. And so he takes her through learning Erlang and says, okay, now we're gonna learn Java. And one of the big differences is these variables, and you can actually change what a variable is. And she just went, whoa. Why would anyone ever want to change what a variable is? Okay? So there is some lingering effect of that. The students, so we had a transition period, we just finished it, where we had students from the old catalog and the old way of doing it still mixed in with the new students. And some of those students were, well, how come, we made it through C++, shouldn't everybody have to? Well, what about pointers? Everybody needs to know about pointers. How can you do computing without pointers? And so part of my job was to point out to them that, when you're writing to the PDP-11 model, you're not any closer to the metal than when you're writing Erlang. Okay, you've got a pointer, it points somewhere. Please tell me where it's pointing. Is it pointing to RAM? Is it pointing, which level of cache is it pointing to? Can you inform me of any of this? And they were like, well, no, because really nobody knows, only the operating system knows that, right? And so as I would have these conversations with them, that helped alleviate the transition concern. The biggest concern they have now, the students that have been through the process, is they want to write for loops all over the place, right? And they want to have if statements and else's and all those kinds of things because that's the first experience they've had and that's what they think is the right way to do computing. And so I get to say, no. There's this thing called map and another one called filter and one called reduce, and you can combine those, and it's really cool. And at first, they're not believers. And it takes them a while before they go, I actually have to debug less code when I do this.
So we have an online question from Grayson. What made you pick Erlang and Clojure as the two functional languages?
Thank you. Another good question. So the group of us that were working on this walked into a room, and we said, well, we've got one person here who really is into Erlang, and we've got another person who's been a Lisper since he was 3. And when we looked, well, okay, yeah, that's who we have, but we can be flexible, we can change. When we looked and went out and said, all right, what's the pay scale? And what it was, Erlang, Clojure, and F# were almost all tied. We're like, okay, we'll go with those two.
The thing that surprises me about this story is that you just get to make up whatever you want to do and call it a degree. And I'm curious how certification plays into this, and how do you, like, how does all that work? Do you just get to do whatever you want?
Pretty much. I mean, it does help that we are not a traditional research university, right? So we don't have to worry about grad school and all that kind of stuff going on. So that helps. Plus our administration is very supportive. We have been very inclusive with them, letting them know what we're doing, why we're doing it, and they love it when you reduce the number of credits required to graduate. Another thing is the ABET accreditation system has dramatically changed. And it's gone from they have to have this class and this class and this class to they need to be aware of these principles. We are not, we have no intention of becoming ABET accredited. Could we? Yes. But we have no need for that. ABET accreditation would not increase our students' graduating salaries, nor would it increase the number of our students who are getting jobs. And so we just don't feel the need to formally go through the accreditation at this point.
I guess my follow-up to that is then what is the value of ABET accreditation? Is it in attracting students and you have such a high student application rate that you don't need to attract students? But like, why does ABET exist then? Because it seems like that's an unnecessary hurdle to allowing curriculums to progress more rapidly and iterate.
I don't speak for ABET. You know, they have their own reason for their existence, and I don't pretend to know what it is. We have amazing students. One difference between traditional universities and BYU-Idaho is we have no minimum SAT or ACT scores. We want to take normal, everyday people and help them achieve extraordinary things. And so we help each student, not just to raise where they are, but each student to excel. That's our intent, to get them to help them excel and all get to this point. And I've seen that. The students that we get are very willing to work hard.
I think this is the last question we have time for.
Okay. You mentioned your qualitative research, but not really any results from that. Could you just maybe mention a couple of highlights that came out from what employers wanted and what graduate schools wanted?
Sure. So again, it was very interesting to us. We thought the grad schools would be the ones that had the real long list of things that were required. What we found was they want people who are interested in computing, that have some passion for it, that have some experience, some level of expertise in one language, but they don't care what it is, and that they have very good soft skills. Both of them said, we want students with very good soft skills. And at BYU-Idaho, that's easy to achieve because in our department, we're working in teams. We're working in teams in almost every class. And we've worked on figuring out how to correctly assess individual students that are working in teams, right? Nobody wants to have a manager that says, oh, the team failed, and so everybody's fired. But the manager should try to figure out which person it is that they need to help. And that's what we try to do.
All right, thank you, Lee.
Thank you very much.